My name is Yossef Mendelssohn. I work for GitHub. I'd like to talk to you about failing in plain sight. As I said, I feel I'm kind of uniquely good to talk about this because I consider myself a sort of failure expert. And again, I work at GitHub. A little bit about me. I started off at a young age watching a lot of martial arts movies, and I was very intrigued with the idea of the ninja working behind the scenes. Nobody really sees it, what it is that you do. For several years, I worked in a consulting firm that specialized in fixing, like a lot of consulting contractors do. We fix a lot of problems. We get called in. We did a lot of rescue missions, kind of like the A-Team. If you're not aware of this, this is just one of many pop culture references that will confuse you. I did this for quite a few years, and then my partners and I, it was just 3 of us, all got hired, or acqui-hired by GitHub. And we're there, and it's a great place to be if you're good at solving problems, because there are a lot of problems to solve. It's not a perfect place, but it's much better than any of the places that I dealt with in all my rescue mission work. So I want to talk a little bit about code, about coding, about programming. This is a creative endeavor. I don't mean creative like this. It's not quite like art, but it's definitely something that you create. There's a lot of creating involved. There's a lot of design work. There's a lot of things that people see. And you really have to think about what's behind the scenes, sort of what's supporting this, what's the foundation, because without a strong foundation, you're going to get into some trouble. Now, when code, when product, when programming gets involved, we have very obvious support. We have the actual support team. We have people like who run the systems, who run the operations. We have security. These are the people that are handling a lot of the behind-the-scenes work, a lot of the stuff that nobody ever sees until there are problems, or no one respects that they're there until there are problems. And when there are problems, it's usually our friends, the support-a-cats, as we call them, that run into the trouble. I just noticed it's a little stretched. It's going to be fine. In addition to all the creative effort, there's definitely an effort of editing, of keeping the message clear, of keeping it on point, of keeping things sort of clean and clear and focused. So with a lot of what we do, this is kind of the effort of the designers. And it's not just in the sense of the visual designers, people who play with, say, Photoshop all day, people who play with CSS. It's definitely a design mindset, trying to make sure that everything you do flows well, that everything has a sort of Zen to it. And we at GitHub, we talk about Zen a bit. We actually have our GitHub Zen, this sort of 14 points, these guiding principles. And you see, there's a lot of things that we really care about. We really care about things being practical solutions. We really care about not being robotic. We really care about doing things the right way. And if any of you have written into support or talked to one of us in person, and we say things like, well, we're trying to find the right solution, we're trying to make sure we do this well, that's kind of this point right in the middle where it says half measures are as bad as nothing at all. We feel for you. We use the product all the time, like Luke was pointing out, but we don't want to do something half-assed. We want to make sure that it is completely there. Say full-assed or nothing at all. And there's even ways that we will show this to you. We see it all the time. I actually was going to say, if you are working on the GitHub product itself, in local development, when you start up the server, these 14 points print out. So you see it all day, every day. But we can show this to you. We have an API endpoint. Hope you can see this. Yeah. So if you ask for the API for the Octocat, you get this nice ASCII art Octocat with one of the points. You can also go to the Zen endpoint, but that's a lot less fun. It only shows the text. And as one of the points said, approachable is better than simple. In addition to all of this effort, we do a lot of tinkering, we do a lot of tuning. We care about performance a lot. The first 2 points there is responsive is better than fast, and it's not fully shipped until it's fast. This I think is maybe the one place where it's okay for people to notice. It's not a bad thing. But to be honest, no one really notices this. They notice when there are problems. They don't notice when things work well. That's natural. That's to be expected. And honestly, I don't know if it's that good if people notice a big speed up, because then they realize there was a problem before. They just want everything to be right. So specifically with performance, with all of this, we want to be scientific about it. We want to make sure that we're doing something useful. We want to make sure we're doing a good job. And for that, we use data. We love data. We love charts. We love graphs. More seriously, we like some charts and graphs. And we have some examples of just things that we show you all around the site, and people love it. This is just what we show you. There are several tools that we use behind the scenes to make sure we're doing a good job, and Luke touched on those. We have the mission control bar that is seen by everyone at the top of the screen when they're logged in, if they're staff. We had a blog post from early September in 2012 called "How We Keep GitHub Fast" that focused largely on this bar and many of the pieces of information we can get there. One thing we can do is see a breakdown of how long the template took, the different parts of the render trace. If it takes a while to render, where's the problem? We can get some information about how much time is spent in Redis, how much time is spent in the cache, how much time is spent querying the database, how many SQL calls there are, even how many active record objects are being created. We can find out a breakdown of the timing. I think this is Chrome only, but as far as I'm concerned, it works all the time because that's the only browser I use. You can see the difference between how much time is spent on the server, how much time is spent in the app itself, how much time is spent with, as I highlight here, the latency in receiving. If you're on a slow connection, it's not necessarily the fault of the app. How much time is spent on the front end once the data is received, how much work the JavaScript is doing. So my joke about this is that there's a very subtle difference in the graph. With the projector we have, it actually is kind of subtle. So there's an experiment that I was trying to do a little something, make it a little better. But I had this idea that it was going to take a little more time for this to happen. So normally when we track data, everything we do, we just add more stats right when we start it, because we figure it's better to have data and not need it than to need it and not have it. So the nice thing about that is when you suddenly find you need it, you have maybe 3 months, 6 months, an entire lifetime of data, and you already have your baseline, you know where things will go, and you can just move from there. This didn't exist. There was no timing information here. So I was in the middle of my experiment, and I wasn't really sure what to do. So I took a little break, and I just added the timing and put it out into production, and then waited a couple days to get a baseline. And then I put my branch out, and it suddenly shot up. And I left it out there. It's hard to see even on my slide. I had it out for 5 minutes, and there's this crazy hump in the middle. It went from around 15 milliseconds to an average of 250. It spiked close to 350. The best case was 150. The best case, it took 10 times as long as the average before. So I quickly pulled it out. I realized that it was a bad idea. I've since improved it, but there's still more tinkering to do. But this is the sort of thing that we use to make sure that nobody runs into problems. And let's say 150 milliseconds doesn't sound like a lot, but we don't want our things to be that slow, and that's the best case. So that's kind of an overview of a lot of the behind-the-scenes work. And now I just want to share a little story, an actual example of this invisible success. So I work a lot on what we call the discussion areas of .com. As I might not have mentioned, .com is what we, on the inside, refer to the website code itself. So I work on the discussion areas, and I just have a natural interest in this, a natural interest in communication, in collaboration. I consider communication to be a core component. Like if you can't talk with somebody, how can you work with them? And I sort of consider GitHub to be more of a collaboration platform than anything else. So I naturally work on this. I work on issues, pull requests, comments. I'm sure many of you will have complaints about this, and I'll be around for that. I do a lot of work with the references. If you've used the references, if you've used the issue management in GitHub at all, you've probably seen this, and here's sort of an example to point it out. Right in the middle of the page, there's a reference. There's a comment at the top from Jake. There's another comment from me underneath that. In the middle, there's a reference where I was working on something else and mentioned this issue. And then there's some more comments afterwards. So it's just this part right here. So there was a big mess, and there was something that I wanted to fix. But the trouble is I wanted to take this, and I wanted to turn it into this. Those are actually two separate slides, I promise. But the real problem is I had to take this, and I wanted to turn it into something like this, right? It's not exactly the way the code looks. It's kind of an artist's rendition. So the trouble was what we had as an idea of the references were seen as just another sort of event for issues. It was originally something we store events like when an issue is closed, when it's reopened, when people are assigned to it. And references were just seen as another event, and that's fine, until you start to think that maybe you want to reference things other than issues. And then you have a big mess. The real trouble is I can't really fix everything. Just the way we ship and the way the mess works is, so I really had to do something more like this. So I had to sort of take a small component and clean it up and kind of plug it back in the hole in the middle of the old mess. And to do this, there were several steps involved. The first one was simple. We had a new model, just a very simple model of creating cross-reference. Then once we had a model, we start using it for some of our experiments, for some of our ideas of being able to reference other things. Then we started recording the data in both places, meaning every time a reference was created, it was created as an issue event, and it was also created as a cross-reference. And this got us to actually extract and make some nice reusable code that can be plugged in anywhere, as opposed to some stuff in issue, some stuff in issue comments, some stuff in pull requests, some stuff in commits. All these things that could refer to issues or be referenced or become referenced, it was all extracted into something. This can refer, this can be referenced. And it was an interesting exercise. And then we got into the data's in both places. All the new data's in both places. Let's transition the old stuff. Okay. That we have, I'm not sure if you're aware, some people, some speakers earlier were throwing out actual numbers. I don't really want to give actual numbers. We have a lot of data and a lot of traffic. It's just, there's really no other way to say it. There's a lot. So I had to get sort of reach into my old bag of tricks and play with SQL and do wonderful things like insert into select and my good friend, the left outer join. This seemed to be great. I thought I had everything done. And then at a certain point, I was ready to switch everything over. And on a whim, I ran this again. And it turned out that there were 40 rows that didn't exist, that weren't in both places for some unknown reason. So then I had to kind of try to find a pattern, wrap my head around it. I couldn't really see it. I worked on something else. I came back. Eventually I found out, or as more stuff came in, over time, I think over 5 days, 124 rows built up, which is basically nothing. It's hardly anything is happening, and I couldn't really find a pattern. But then it hit me, and I figured it out, and then I pushed that new code, and then no more rows came up. And then I transitioned the old data, and again, no more rows came up, and I figured it was good. There's really no way to be sure, because what's the saying? You can prove the existence of bugs, but you can't prove their absence. And when things happen this rarely, you just don't know if you actually fixed the problem or if just the weird thing had stopped happening. But everything seemed okay. And then this was the big step. This was the sort of make or break. we wanted to switch the view to use the cross-references instead of the issue events. This is where I could either fall on my face in front of everyone, in front of all of our users, or no one would notice a single thing. So locally, I had this at a certain point where I was showing both references at the same time. The one on top is the issue event, the one on the bottom is the cross-reference, and it's the exact same thing. For a short while, it looked kind of like this when I screwed something up. It's a sort of a bad nesting problem, and I figured that out. And if you could actually read the timestamps there, it apparently took me around half an hour to do it, or about half an hour between making the two screenshots. So then everything was switched, and it was fine. No one noticed. It's like that magic trick or that sleight of hand where you have the table with the tablecloth and everything on it, and you just yank the tablecloth out, and nothing moves. Except it's even harder because you have to yank one tablecloth out and shove another one in. I suggest you try it sometime. I'm not a magician, but I'm sure it'll be hilarious if you try. So once we get this, it gets to the point where everything else is just cleanup, right? Then we're sure that cross-references work. We don't have to record the issue events anymore. After that, we can delete the old references, and everything's fine. That's just kind of a little Boy Scout material, leaving things better off than you found it. And everything's fine, except this is something that is done on .com when you have access to production data. And you have the good points of that you can tinker with whatever data is necessary and see what's going on. But you have the bad points that people are continually accessing your data. You have to do all this live. We can't really take the site down for maintenance. We definitely can't take it down for a weekend. We can barely take it down for 5 minutes. We have another thing, I'm not sure if you've heard of this, called Enterprise, which is essentially, it's essentially github.com, but bundled in a VM and run on your own local network. This has a whole new set of problems a whole new set of benefits, but a whole new set of problems where we don't have access to it. We can't just go into the console and fix everything. So everything that I did, those 7 steps, had to be bundled and written cleanly so it can be automated. So we can just say, here's your upgrade to Enterprise. Everything's going to work, no problem. And from everything I've heard from support and from the Enterprise team, the same success, the same invisible success happened there. Now, I consider this a success story, but there's still one thing that I broke, and that's this right here. Now, we care a lot about URLs. We try to make sure that everything makes sense. It's a very well-crafted URL, and it's every resource, like every repository, every issue, every user has a URL that you can get to, and it's consistent, and it's reproducible, and you know that if you go to this URL or you click on this link, you'll get it, and you won't be redirected somewhere else that makes no sense, or you won't get a 404. Sometimes, though, we build some things and we make some bad decisions at the beginning. So what I've highlighted here is actually an anchor. It's if you click on this, then you will get a link to an anchor that goes to midway in the page, that goes to this part of the issue discussion. Now, this was using the database ID of the reference itself, the old issue event reference. There was no way that I was going to try to bring over the database IDs. It just wasn't worth the effort. It was going to be a hack at best. Any solution was going to be troublesome. So what we did is we switched it to use the source of the reference. So before, this would have been something like, if I remember correctly, pound issue ref dash and then some number like 3576, whatever was in the database. So what we're doing now is we take the source of the reference. So this is coming from a pull request. So it'll be ref dash pull request dash whatever the database ID of this pull request is. So whatever we do to change the references, that's not going to change. I felt kind of bad about it, but there was really no way about it. I also had sort of a short and thorough debate with one of the people also working on this about maybe we should make it even shorter. Like, why say pull request when we can say PR? Why say issue when we can say I? And he kind of talked me down from that and pointed out that, you know, maybe in the future we might want to have models called, say, insanity or pork rind. We don't really want to make sure we can't do that. And I just wanted to make sure that this will be the last breaking change, that from this point, people will know that the links go exactly where they want to. And we figured it wasn't a huge deal because it'll still take you to the right page, just maybe not the right part of the page. So that's actually all I have. That's kind of my invisible success idea and story. So if there are any questions, I can take them now, or I'll be around later throughout the day and at the drink up tonight. Yep.
Yeah,
oh.
Question. When you switched the templates, the problem with rendering, and you were worried if it will break for people, couldn't you have it rendered twice and display the old one and compare the string to the new one and run it for a while in production to actually check that, you know, the rendering is identical?
Yeah, okay, so the question was when I was worried about switching the templates, is it possible that I could have it rendered twice and check, compare the strings, see what it was like in production? Part of that, it wasn't honestly that I was personally worried. It was just kind of this is where it could break. And then we do have, I did a lot of local testing with a lot of references, and that's why I had the double there. And another thing that we have is it was kind of, let me see if I can easily go back to it. In the staff bar is that we have this really easy way of testing changes with production data, which is if you see, so we have this special staff-only front end called the GitHub Lab. And what it is we can deploy code to there, and it uses production data. It's kind of like a staging server. It's kind of a special front end that only we can see. So I could deploy it to the lab, and I could look at the exact same page in two different ways and see this is what it looks like for production. This is what everybody's going to see. This is what everybody's going to see when I deploy this change. It looks the same, except for the one change that I mentioned before with the anchor. That's perfect. Any other questions?
So you described a kind of a frightening process in which you don't know if it's going to be a success until, you know, nobody complains for a year. So I wonder, since then, have you developed some kind of, you know, better processes for, you know, getting more certainty before going to production?
Okay, so you're asking about the sort of uncertain process. And if we've developed tools for more certain processes. Part of that comes from a lot of personal experience, you know, all the rescue missions. There are many things that my partners and I did where there were no tests whatsoever. There was no way to really know what was going on. And we did a lot of refactoring, and we did a lot of what we call sort of, I can't actually remember the word right now. There's a lot of behavior tests to cover what the system does right now. Because sometimes that's all you can do is, you know, you need to change a lot of code. So you write a lot of tests that cover what the system does at the moment, you know, even if it's wrong and stupid. But what you want to do is make the code a lot easier to deal with without changing the behavior whatsoever. And then once the code is easier to deal with, then you can change the behavior. So we've done a lot of that, and then also, as I was mentioning to Vitaly, having some processes or some special sort of staff front ends, if for an example like this, where you can compare the data and how it's presented in both cases. Is that good? I mean, we can talk more later. I'm sure you can grill me about all sorts of things. Yeah. Well, I mean, a lot of it is for as long as automation is concerned, a lot of it is you can do things like create all these automated tests to see this is what the system does now. And sometimes what the system is, it's so opaque, it's such a black box that all you can do is kind of write some tests and see what answers are brought back and say, okay, that's it. I assert this. It has to be 5. Apparently, that's the answer you're going to give me. And then you change the code and you make sure it still says 5 in that situation. All right, anything else? No? Thank you very much.